Consider that what you're seeing is just a tiny fraction of the multitude of celestial bodies that make up our universe. Its size is so immense it's almost unfathomable. The universe is filled with galaxies, each hosting millions, even billions of stars. And here we stand on our little blue planet, trying to measure the immeasurable. How do we even begin to comprehend such distances? Well, we start with light. Light, the fastest thing in the universe, the constant traveler, never resting, always moving. We use the speed of light to measure these incredible distances. And this measurement is called a light year. So let's open the door to the universe and embark on this cosmic journey together. So, what exactly is a light year? Is it a measure of time or distance? This is a question that has left many scratching their heads. The term light year might be a bit deceiving, as it's not a measure of time, but rather a measure of distance. Let's dive in to unravel this mystery. Picture this: light, the fastest thing in the universe, dashes through space at an astounding speed of approximately 186,000 miles per second. Yes, you heard that right, per second. When you try to wrap your mind around the vast distances that light travels in just 1 second, it becomes difficult to truly comprehend. Imagine taking a trip to the moon and signaling your friend as soon as you arrive with a laser. Just 1 second later, your friend can see you've arrived safely. It's faster communication than making a phone call on Earth. Now, as we start to visualize that incredible speed, consider this: while light may be the fastest thing in the universe, it also has its limitations. Every time you gaze at the mesmerizing moon, you're actually seeing it as it appeared 1 second ago. Now, I know what you might be thinking. 1 second, that seems insignificant. So let's shift our focus to the sun. It takes approximately 8 minutes for light to travel from the sun to reach Earth. So even if the sun were to suddenly collapse, you would still have about 8 minutes to enjoy its light, its warmth, and even its gravity, even though it have already gone. Now, let's venture even farther. Neptune, the outermost planet in our solar system. The distance between us and Neptune is constantly changing as we orbit the sun. However, on average, it takes about 4 hours for the reflected light from Neptune to reach us. And that's only the start. When we gaze at distant celestial bodies, we're not just seeing them as they are now, we're seeing them as they were when their light first started its journey towards us. This is due to the concept of time dilation, a fascinating consequence of Einstein's theory of relativity. As we gaze further and further into the cosmos, we're actually looking further and further back in time. Let's take a journey back in time. We are now venturing beyond our solar system, encountering distances measured in light years. A single light year is approximately 10 trillion kilometers, or about 6 trillion miles. Our earthly measures, miles or kilometers, fall short in the face of cosmic distances. For instance, the nearest star to us, Proxima Centauri, is about 4.2 light years away. In terrestrial terms, that's nearly 25 trillion miles. Using light years makes these astronomical distances a bit more digestible. 4.2 light years may sound like we are close neighbors. However, let's consider this. NASA's Voyager spacecraft travels at an astounding speed of over 56,000 kilometers per hour, which is approximately 16 times faster than the fastest jet aircraft in the world. Despite its incredible speed, it would still take the spacecraft over 80,000 years to reach our closest neighboring star. Forget about our neighbor. The Pleiades star cluster is located 400 light years away. When you gaze at the night sky and see their shimmering light, you are observing light that is much older than you. When this light departed from its star, Galileo himself was studying the stars. Consider the star Betelgeuse, for instance. This red supergiant is about 640 light years away. So the light we see from Betelgeuse tonight actually left the star around the year 1383. That's during the time of Chaucer and the Peasants' Revolt in England. As we continue our journey, we can see the light from the Crab Nebula, situated 6,500 light years away. It may seem like a considerable distance, but in reality, we have only just begun to explore our own galaxy. So what about the distance light we observe from the center of our galaxy? It actually departed approximately 26,000 to 30,000 years ago, when our ancestors were living in caves. So far, our travels have been limited to partially of the Milky Way galaxy. Let us venture even farther into the unknown. The Sombrero Galaxy, also known as M104 or NGC 4594, is located approximately 31 million light-years away from the Milky Way galaxy. When the light we observe today left these stars, humanity had not yet evolved. Nevertheless, this galaxy is the nearest neighbor to our Milky Way. Furthermore, we can see the Coma cluster, also referred to as Abell 1656, is situated 320 to 321 million light-years from Earth. When the light from this cluster began its journey towards our planet, the continents, seas, and the Earth itself were very different. Life had just transitioned from the oceans to the land, taking its first steps on terrestrial ground. And the farthest and oldest light we've observed is from an ancient galaxy, approximately 13.4 billion years old, captured by the Hubble telescope. This light allows us to travel back in time, witnessing the early first generations of stars, the formation of our planet Earth, our solar system, and the entire Milky Way. Took billions of years to come into existence from that point. So what lies beyond the first generations of stars? Well, we cannot see beyond. It appears to be the edge of the universe. However, let us not be fooled by appearances. It is not the end beyond this point, but the beginning. As we journey through the cosmos, light years become our guiding map. Trying to measure the universe without year light is like trying to measure the breadth of an ocean with a ruler. It just wouldn't work. This vast universe, so seemingly infinite, becomes comprehensible when we understand its language, the language of light years. Light years impact our perception of the universe. They allow us to glimpse into the past, to see stars as they were millions, even billions of years ago. They reveal the profound influence of gravity, bending and warping the path of light itself. The next time you look up at the night sky, remember you are not only enjoying the beauty of the cosmos, but also engaging in time travel. If you enjoyed this video, join us as we delve into the deepest secrets of the light. Click this video right here.